Okay, we're going to talk about linear regression, and we're pretty much just going to focus on lines of best fits and finding equations for a line of best fit. Okay, now this represents, this is a grocery store. I think. Okay, this is a grocery store, and it's sales. So these numbers are all in hundreds of dollars. Okay, and so first part talks about weekly sales of Y. Y meant how much money the company is actually getting. So how much money this grocery store got each week. So let's say this was week 1, week 2, week 3, week 4, week 5, week 6. So they ran an experiment. What their experiment was is X was your explanatory variable. Is it A-T-O-R-Y? I think so. Your explanatory, or as we call it, the independent. Yeah, we know it as independent. Okay. And your Y was your, you call it response? Yeah. Response variable, or as we usually call it, is the dependent. It depends on the other. It depends on our X, okay? So what this was trying to explain is the amount spent on advertising. So this company, and we're going to convert these numbers so they make sense to us. In the very first one, this is the number 1 times the 100 because it's in hundreds of units. So in other words, they spent $100 on advertising. In week 2, they spent $125 on advertising. And the way I'm figuring that out is I'm just multiplying each of these numbers times that 100, okay? Which means we spent 150 in week 3, 200 in week 4, 250 and 300. So it looks like they went up $50 every week, right, in terms of their advertising. Now the amount of money they made increased. Maybe if I bring this down just a little. Now we won't be able to fit it in there. I'm just going to write it right underneath in blue, okay? So this amount, they actually made $1,020, okay? This is their Y's, okay? I'm just putting it below so we can get an actual dollar amount. This one, they make $1,150 in week 2. The next week, they made $1,610. Then we have $2,030, 2,560, so $2,560, and $2,800 in week 6. Now, if you look, it looks like these are increasing, even though it went up by, what, 25? Oh, we went up 25, 25, 50, 50, 50. So we changed the amount we were going up, okay, which makes this a hard model to go after. So what we did is we just plotted our data, and this is what they found. On the X was the amount of money they spent. So they just put it in units of 1 to 3, right? But it's really representing $100 to $300. And here we're really representing $1,000 to $3,000. And this is how it seems to increase. Well, if we look, it looks like we are getting a straight line. There is some type of linear regression to this, right? I could kind of draw a line that goes like that, and that could be considered somewhat of a line of best fit. What we're going to try to find is the best line of best fit, okay? So we got to find that out. And this is the equation of a line, of a linear line. M deals with slope, okay? And slope is known as your rise divided by your run. It's your rise over run. So let's zoom in again. I'm going to zoom in extra close here. So rise over run would kind of be like, it's really hard to see here, but this is how far we go to the right and how far we go up, okay? So it kind of looks like every time we go over, well, actually, here would be a great example. Let's expand this a little. Well, if I'm starting at 1 and 10 and I go all the way to 2, so this would be my run. It looks like my run was I went 1 unit, right? So in other words, in this case, that's like $1, you could say. We've gone up from 10 to 20. So this is our rise. It looks like it went up 10 units, okay? So this is an estimate. So in other words, our slope, if we were just to estimate this, our rise is 10 units in this case. So kind of like looking at this as 10 divided by 1. Well, 10 divided by 1 is 10. So it looks like the slope of this might be the value of 10. B is considered the y-intercept, and the y-intercept is when x is equal to 0. So when our explanatory variable is 0, okay, so when, we're going to call it y-intercept. And that's essentially when we're crossing, I'm going to show you, the very beginning line. So this line right here, when we're starting, that represents an explanatory variable of 0. Where are we starting at? And it looks really low, maybe like 1 or 2, okay? So we estimate that maybe B will be the value of 2 or 1, something like that, okay, by looking at this. What we're going to do is we're going to get into this model here, and this is actually solving for it. Okay, we're going to need a little more information. We're going to need things like standard deviation with our regression model. So we estimated our line, okay? So in other words, we estimate, and I'm going to fill it in now, that our y is representing the response. We can figure the response variable by taking the value of 10, which is our slope, and multiplying it by any of the explanatory variables x, and we'll say, well, I don't know, plus 2, plus 1, something like that, plus 2. So in other words, what it's saying is, if we spent no money, we'd be at the number 2 down here. We had to really estimate that. And for every, you know, maybe dollar, if I put 1 in here, this will tell me how much money I have, or how much, sales I'm going to get. This is essentially what this is going to figure out. What we'll do is we'll actually solve the actual regression model to figure this out. How we do? No, 6 minutes. Okay, so we'll jump to the next page. We need this information to solve this, okay? Like we said, this was the model we needed here. The B1 represents our slope from before, okay? This is essentially our slope from before. And the B0 is actually our B, or our y-intercept, okay? So I'm going to call it y-intercept. I know the color is getting confusing. That's the blue. I used blue last time, and I used green for slope, okay? So that's what this represents. So we're going to solve the same things, but we're going to be very exact when we do this. So in other words, here's our slope, and here is our y-intercept. The y and the x are still involved here. Do we use a hat for the x in the equation? No, I don't think so. No. Okay. So what we can do is we can use this information to extrapolate data. First of all, to calculate the slope, it says what we need is our r multiplied by sy divided by sx. Well, what do those mean? Okay, r is our correlation, okay, and I think it's the correlation coefficient. Now, they've given us the correlation of sales and ad cost to be 0.99. So we'll call it correlation coefficient. I spelled that one way off. But anyways, correlation coefficient, that's our r. So we're going to be plugging in 0.99 for r. Okay. The sy is the standard deviation of our y variable. So standard deviation of y. Sx is SD, okay, for standard deviation? Mm-hmm. Standard deviation of x. Well, standard deviation of, remember, y was sales, and advertising costs were our x. Explanatory and response, right? So the standard deviation of y is 7.33, so that's where this is. And the standard deviation of x is 0.77. So we're going to have to figure out our B1 from that information. So B1 we said was equal to r times sy divided by sx. Well, it turns out that r is equal to 0.99. That was our correlation. Sy, standard deviation of y, is 7.31, we'll say. Okay? And sx is standard deviation of our x variable, which is 0.77. So, scroll down to the bottom here. What that means is B1 is equal to 0.99 multiplied by 7.31 divided by 0.77. Okay, well I can do this all in one shot on my calculator. We'll do the brackets first, right? 7.31 divided by 0.77. And then we got to multiply that by 0.99. We get 9.398. 9.398, let's say, okay? So B1 is equal to, what did I say?
9.318.
398. Okay? So that's our slope. We just discovered the slope. What did we estimate the slope to be in the other one?
2.
No, I think we estimated it to be 10.
Oh, 10.
Right?
Oh, yeah,
We jump back.
Intercept, sorry.
Yeah, our slope was 10. We had a really good estimate. That's really close to 10, right? We had a really good estimate for our slope. So we can already start to put together our equation. Now here's the harder part. We actually have to calculate the B1 first in order to solve for B0. Okay? And the reason being, B0, you need to actually have the B1 value involved. So this B1 value is important for B0. Okay, so B0 is equal to Y bar. Y bar is our mean. So mean of Y, so I'm going to write that down. Y bar equals mean of Y. X bar is mean of X, right? And B1 was what we solved over here. So let's jump back up here. Perfect. The mean of X is 1.875 and the mean of Y is 18.61. So let's actually write those values in. Minus B1 times X bar. So we already figured out that the mean of Y, actually it's due in red, sorry, so we can kind of keep these apart, is equal to, what did we say it was? 18.61. Okay, 18.61. The mean of X, so all this information needed to be found for us before, 1.875. It's equal to 1.875. And what is B1 equal to?
No, 9.3.
Yeah, we're going to be exact as possible, 9.398. So in other words, we plug this info into our equation. So B0 is equal to Y bar, which was 18.61, minus B1, which is 9.398, multiplied, that means multiplied by the mean of X, which is 1.875. Okay. Again, we can do this on our calculator really quickly. I'm just going to do some bracket stuff. Okay, so 9.398 times 1.875. And we got to get 18, subtract that value. So I'm going to write down 17.621. So minus 17.621. Okay. So we have 18.61 subtract 17.621, 0.989 it looks like. 0.989. So that's really close to 1, the B0. Remember we said it was going to be 1 or 2? Well, we were off by a bit. We went a little too high to start. So the y-intercept is 0.989, assuming we did that all right there. So let's zoom out a little, entire page. Our formula, we'll write it in. Our formula is the y hat is equal to B1, which is 9.398, times X. X is our explanatory, plus B0, which is 0.989. So in other words, we look at our dual pages here. Let's scroll down a bit. This was our linear regression model, which is really close to y equals a slope of 10 plus 1. Okay? And if you notice, that was pretty close to what we estimated. We'd estimated 10 and 2. It turns out when we actually solved it, it was 10 and 1. So that's how we go. And what that did is that found the exact equation of this line. So we should be able to interpret data from here with this information. We should be able to, sorry, this is the one I wanted to highlight. This was our actual one here, right? We just kind of estimated down there. It's really close to 10 and 1 in terms of an answer here. I know that's a lot of information.